This video is going to be a lot of talking about some of the concepts and considerations for elevated storage and trying to build a lift, in my case out of garage door opener, to help with some of the elevated storage, getting things up and down safely. If you're looking for a how-to video, step-by-step instructions, this isn't going to be that. There's just too many considerations that change from one project to another, and in my case, the garage door opener was here and I built it, and there's just a lot that can go into doing this well the first time. I'm not saying I did it the best, but in any case, this video is going to be a lot of talking, narration, pointing at things, kind of talking through all the things that somebody might want to consider for a project like this. So if that's not what you're looking for, go ahead and save yourself the time now. Otherwise, we'll get into it. I'm tucked back here about as far on the corner as I can get to try and give a decent view of things for now. And the first topic is to talk about maybe some of the benefits of using a garage door opener versus trying to build something from scratch, or thinking to just salvage the track from a garage door opener and use a separate winch with just a forward and reverse or something. One is that the garage door opener is powered up and down. That can be helpful if your carriage starts to bind at any point, or you have any resistance in the system. For example, if using a winch, you would have to probably add extra ballast weight to the carriage, so it definitely feeds down when the cable or whatever spool is being paid out. Whereas with the garage door opener, it's powered down. And, I mean, that's going to just give you a more consistent behavior. That's a small one. These are in no particular order. The auto stop at the top and the bottom is super handy. In my case, as I'll show in a bit, I've got a button at the top and bottom, and that way I can trigger it to cycle from the top or the bottom, wherever I want to be able to supervise it from, or load and unload, or catch things if they're falling, if it's safe to catch them. There's the adjustable top and bottom start and stop positions. In this case, that on mine, there's a nut you feed along a screw, and that is where it triggers the start and stop contacts. It's going to vary by manufacturer. There's the safeties. If it hits something or gets overloaded, it will automatically reverse. Newer ones, of course, have the infrared fences as well, which can even be useful for making sure that your floor is clear before you lower the platform down to the floor or something. There's the adjustable, at least on mine and probably in general, there's the adjustable open and close force, which is going to change probably the limit of where the safety is, how hard it pushes before it gives up and backs up. That's probably useful, and you could just max it all the way to increase your capacity before it trips the safety as well. Of course, that's the whole package. You have the existing track, chain, and motor all together, so it's a great platform to just get started with. Well, maybe you figure out how you want to change it or what you'd replace it with over time. They're super cheap. In my case, they're pretty much always available on Craigslist. It looks like there's always half a dozen on Craigslist around here for under $100. In this case, I got this one for free because it was sitting in somebody's shed. I picked it up before I even knew what we were going to use it for. I thought I might actually use it in our garage at the shop here. But it was sitting in their shed, untested. They didn't have any other parts, no remotes for it, no wiring, no nothing. And you don't need any of that stuff. You really just need the main unit, the track, the chain, all the main components that are on the assembly itself. Overall, it's a great platform to start figuring out what you want to do with it, and then you can figure out how to customize it, change it over time, or replace it with something that is built from scratch, but now you know what your requirements are. In this case, I put this in about 6 or 8 months ago because I built the elevated storage platform to make better use of the floor space in the shop back here. I needed more floor space when I brought my Bridgeport in last spring. and as a result, um, I wanted to get my storage off the floor and use the floor space for more valuable things like machines and workspaces. So that's the big picture of why I think a garage opener is a good starting point for this. My capacity on this is about 80 to 90 pounds. That's with having a counterweight I added, which we'll talk more about later. So as far as planning, uh, placement is one consideration. I'll walk over and show mine in a minute. The You need to make sure you have the space for it, obviously. Figuring out where your elevated storage is if you haven't built it yet, where it's going to be. Start thinking about where on your storage, if you haven't built it yet, think about where you would want such a lift to be. Are you going to be on a ladder while you're trying to unload it or load it? What's the max weight you want? What's the platform size you want, for a bin or a flat platform? Is this even the best solution? Do you want an overhead, lift with a chain, maybe some kind of cheap hoist that lifts things up with slings or hooks? In my case, I was thinking about putting a jib crane up on this post here and lifting things because I had an extra chain hoist available to me. But I realized that most of what I'm storing up top is going to be small things that don't have a logical lifting point. I end up having to put them all in a crate or a basket to lift them from a chain anyway. And I realized that a platform style lift where I put a bucket or a crate on it is going to be better for me, especially for some of the machine parts or vices or lathe chucks and other things. In my case, I reach over the edge up top. I might want to add a railing or something at some point that I can lean against or catch myself if I'm lifting, but there's a lot of maybe safety aspects of how is your center of mass going to change when you yourself are lifting things on and off of this, potentially in a compromised position like on a ladder or reaching over an edge. The main impetus for me is I wanted to put this in because I have this fold down ladder here. And right away, as soon as I was going up and down a ladder to put things up there, I realized there's no way I could store some of the things I want up in the elevated storage and get up and down the ladder safely. It just was out of the question. Anything more than something I can hold with a few fingers in one hand, with how steep that ladder comes down, was out of the question. If it was a little more like stairs, maybe be okay. But even then, a stair type thing without a railing, it would just be way too unsafe to be carrying something like this lathe capstan here. This is probably 85 pounds. And that was something I realized that I would want to be able to store out of the way when I'm not using it for a while. But I do not by any means want to be carrying it up and down a ladder. It's just, it's not even possible, but it's far from practical, even if it was possible. So I wanted a platform I could strap things to, and I wanted my max weight to be upwards of 85, 95 pounds. If you need to go higher up, you may not want it mounted all the way to the floor. The end, as you'll see, my track ends basically at the floor. If this was a 12-foot platform instead of an 8-foot platform, I might need to have the whole thing either mounted a few feet, in general higher up, or also look for garage openers with a longer track. I think it's probably very impractical to look at extending the track and chain, at least when you're first building this. That's an extra hurdle it's not worth taking on. So find one that's long enough for what you want, and consider moving it so that it sits higher if you need to be able to get extra elevation to your elevated platform, or to make loading and unloading at the elevated position easier. You don't need it going all the way to the ground. This thing's not going to be lifting 300 pounds where you need to load something on with a hand truck. You're probably going to get 50 to 100 pounds depending on how you set it up and what maybe counterweight you add to it. So it's really about ease and safety of loading and unloading. In my case, it comes down to about mid-thigh height for me, and that's perfect for being able to put things in, especially when it is something a little heavier. You probably could put the motor at the top or the bottom. I think it's easier to keep it out of the way up top. If it's at the bottom, the garage door openers in general are meant to lift weight. The garage doors are counterweight with springs typically. So the garage opener is not lifting a ton of weight, but it is generally lifting. The garage doors are not biased to close under gravity. So naturally this will do better if you have it lifting. If you put it at the bottom, you probably would need extra counterweight on the platform, so it wants to go up more. In addition to adding a counterweight to gain capacity. So you could put the motor at the bottom if you needed to avoid an obstacle overhead or just didn't want to look at it up on the wall or something. Whatever considerations might go into that. Similarly, you could probably use a screw type garage door opener, and that probably could actually have better lifting capacity if I had to guess. But in that case, you almost certainly need it at the top. I think the screw is not going to do well under compression, so you're going to want to have it pretty much always loaded downward. Whereas if you have it at the bottom, you would need to make sure that you always have enough counterweight that even at max capacity, the platform wants to go up. See, I have mine placed between a lathe and a bandsaw here. I just happen to have this dead space between them, which is it was intentionally kept open originally because it's how I access the inside of this machine when this cover opens, and then behind this sheet metal is the door to access the base of the bandsaw where the motor and controls are for that. So this space is naturally not available to use permanently. I started keeping the shop vac there, and I end up having it live there specifically with the carriage height at the bottom of its travel not hitting the shop vac or whatever else might be temporarily stored there. So at the bottom, I have a welded up bracket. This is made from some angle iron that I think was an old bed frame that I cut up and welded up to bolt this to the ground. It's floating the end of the track about an inch and a half off the ground. And that's because I wanted most of the weight hanging from the bigger bracket at the top. I don't want the track here in compression where it might buckle under load, or maybe if it was under axial load, it would start to wobble more as things are wanting to bend it and it wants to flex side to side during when the whole machine is moving. So I had it originally installed hanging off the floor and then fit the bracket in as kind of a snug fit. So my plan is that most of the weight is hanging from the big bracket, which is a big piece of angle iron in my case, but that's overkill, up at the top. And then this is just to stabilize the end, and then it translates some load into the ground, but not the majority of it. I have a block of wood attached from the back to the wall. That's just to help keep the track from deflecting and wobbling. And then I also ended up welding the seams in the track closed. This is a modular track because this is, was originally probably sold as a box kit. I think this was a Sears item. So this was meant to be something that could be sold probably in a box on a shelf, and the track was modular. I ended up welding the track because my guide rollers were hitting that and bumping around a little more than I wanted. The cardboard here is just a cardboard cutout to keep the shop vac from hitting the greasy track. And that's, of course, below where the table stops. Now, as far as the table itself, it's going to be sized to what you want to be able to lift and have stable kind of control over. In my case, it's more the bed frame. I intentionally chose that wide part for the end so that the OSB is stabilized by it. And then I shimmed with plywood to get a level surface for the OSB. This was done with just scraps of what I had around, and it's ended up working well enough that now it's kind of permanent. So I tacked the frame together, and of course the carriage on these is not meant to handle this kind of load. This is meant to be sliding horizontally overhead where the load is all on the back of that T-track. So in order to be used vertically, it will need some kind of angle, brace like this. So in my case, it's a piece of angle iron I tacked on at about, welded on at about probably between 15 and 30 degrees, like a kickstand almost against the track. And then I took some old bearings that I had cycled out of a piece of equipment and used those as rollers that ride on the front of the track. In my case, I stacked up washers with bigger ones on the outside edges That's to help keep the bearings on the front of the track. Without those, this would want to twist and maybe walk off the side of the track, depending on how the platform is loaded. And that's obviously not desirable. So I just stacked up all kinds of different washers I had on hand, and I turned a couple spacers on the lathe to get these all to kind of sit right and have the bearings fit on the half-inch bolt that I'm using as an axle or a center shaft for all of that. So the top of the platform in my case is just this carriage bolted piece of OSB on. It's probably 12 by 20 inches or so because it was just a good fit for here and the types of things I would be lifting up. I usually keep this yellow bin on there because that way I can throw smaller things in that I eventually want to organize up top, or as I'm pulling items out of storage up top, I can drop them in and not have to worry about them rolling or falling off the edge of the platform. As I mentioned earlier, I think that pretty much all of these deserve a counterweight. In my case, I have a piece of cable going from the carriage up parallel to the track to another bracket I welded up here, and then I have two pulleys to redirect that over and then down along this vertical post to this counterweight. In this case, my counterweight is just a big chunk of steel that I welded a feature onto so I could attach the cable, and that's about 40 pounds. When I first started using this, I found that it really, without the counterweight, it really did not want to lift more than about 30 pounds. It started getting pretty sketchy around 35, and around 40 it would trip the safety and automatically reverse, especially when it hit the seams in the track. So what I did was added a counterweight which would bias it upwards by about the same amount. If I figured that the capacity of the motor before it hit any safeties or load limitations was, let's say, 35 to 40 pounds, I added a counterweight equal to that, and it probably could be a little heavier for the carriage weight itself. And that has brought me between 80 and 90 pounds of capacity total. The difference is that now the platform naturally wants to go up, but that's fine. With no weight on it, it does cycle completely fine. It just changes which side of the chain is in tension, depending on whether the load on the platform is greater than the counterweight or not. When I have, let's say, 20 or 30 pounds of stuff on here, the load is basically neutral, like an elevator, that has a big counterweight. So the motor is doing very little work. If I needed to increase the capacity more someday, because when I have this at max load, I do notice that the chain gets really slack on one side. And what I'd probably do is there's some springs in here for tensioning the chain. I probably would need to double up that spring to add more chain tension, and then it would not get so sloppy when it's going up or down under high load. But I don't think I need to push the load of this, or the capacity of this, beyond 100 pounds. That's it's probably between 80 and 100 pounds today. Next, we'll probably be talking about the order of operations of installing and building this. I ended up installing this kind of piece by piece, figuring out as I went, and that ended up being I think a pretty good way to do it. I didn't try to design everything up front. I didn't really do anything more than just sketches on certain geometries throughout it. I didn't do like a full CAD design of this or anything. What I did was I made this bracket first. Once I realized that the motor should be up top, I made this big bracket for attaching it to the 6x6 at this corner of the elevated storage platform. I figured I would design the carriage and figure out how to attach it to the floor later. I did know that my height would be pretty good with this basically at the floor down below, so I did not worry about trying to get this a foot or two higher in the air. So once I took careful measurements of the width from the flanges on the back of here, I then welded on some angle iron tabs. In my case, this is of course specific to how you install it, but I have angle iron mounted inside, which I welded some nuts to so that I could use 1/4-inch hardware to bolt it together. I ended up attaching the mechanism, the motor, to the bracket on the ground, and then lifting the whole thing up here. Now, that made it very end heavy, especially because my bracket is made out of that big piece of angle iron. So in my case, I attached a hook to the top of this post and used a come along to lift this up a little more slowly and controlled. And then I was up here and my wife was down below just stabilizing the end of this for me. Once it was here and I got it onto the 6x6, in my case I made these brackets a very snug fit on the 6x6. I actually had to use some clamps, like big C-clamps, to draw it onto the 6x6 because I wanted the twisting moment of the load to translate directly into the 6x6. I didn't want the fasteners to play an important role in translating that load to the 6x6. So you can see I just have decking screws in these pieces of angle iron that connect to it, and it's pretty close to the back edge. It's not like I fastened it right into the middle of the 6x6. And that's because I just knew that the twisting moment, with those brackets being such a snug fit on the post, that would translate the load for me. So once it was up here, then I made the bracket for down below. I actually, when we stood it up against the wall, I put a 3/4-inch board under the end, or maybe it was a 2x4 under the end of it, so that it wasn't on the ground. So once it was bolted up here, it was hanging in the air when I pulled that board out. And that was just so that I could get measurements of how the bracket would attach it to the floor with most of the load hanging up top. I only wanted a little bit of the load in the floor, and then as this either sags or deflects over time or under load, then that would increasingly go into the floor a little bit. But I just did not want the weight on the track trying to buckle it from day one. Then once this was in place, I did the bracket at the bottom to attach it to the floor. I made sure that it would actually travel up and down now. I didn't want it to twist. If the track was twisted by the time I installed it and it couldn't travel up and down, I wanted to know that before I got any further into the project. So once I knew I had it mounted and traveling, then I worked on the how to make the carriage and the platform. So what I found is that once I had this mounted, it was better to make the platform kind of with it mounted in place. I found it easier. So when I was doing that, I would unplug the power with the platform at kind of useful face height. That way I could work on it without crouching down or up in the air on a ladder. But for now, I've got it down all the way. And what I found is that indeed it was easier to visualize like the forces at play. It was easier to visualize how I wanted things to come together versus if this was laying horizontally on the ground. If the track was on its side on the ground, I'd have a harder time kind of picturing how this would come together. Maybe that's just me, but I liked in hindsight that I was doing this kind of in phases as I went, solving problems as they came up. One side effect of that, for better or for worse, is I didn't commit a lot of time into doing any part of it. It was a couple hours here and there of, okay, what's the general idea of how this is going to get installed? And then it was, okay, what are the detailed measurements to make the bracket for up top? And then the next time I was in here, it was, all right, let's figure out how to get this up into place. And then the next day I was out here working on it. It was, all right, now let's make the bracket, for the base, which is 3 pieces of angle iron. And then I've got some 1/4-inch sleeve anchors going in the ground. And then after that, it was, okay, now I'm going to figure out the platform. And then once I had the platform and tested how much weight it could carry, I realized I needed the counterweight system. So then that was the next, project, a couple hours. Each one of these things was basically 2 or 3 hours, maybe. So then it was the counterweight. And then once that was all working how I wanted, it was adding some actual buttons for the top and bottom. And in this, these are just single, pair of contacts, momentary, normally open buttons with some speaker wire, because this is like 24 volts AC or something. It's not high voltage. So each of those are in parallel so that either button closes one wire to the other, one conductor to the other, and then that triggers the relay logic inside the opener itself. So overall, I think this probably took maybe 12 hours. You know, between what, five-ish steps, you know, phases of work, and each of them was 2 or 3 hours. So let's say 10 to 15 hours. And it's been working great for the last 6 months. I've had to make 0 changes after that initial work. I did tweak, you know, where it stops in the high and low position for, you know, once I realized I wanted to keep the shop vac under there, and I was deciding whether I wanted it, you know, level with the platform or just above it. You know, it's kind of a moving target. And yeah, that's about it. I mean, my total cost on this, almost, I had a lot of this stuff already. So I had the 20 feet of that angle iron. I had a bunch of these pieces of bed frame. I had to buy maybe one of those eye bolts used for holding the pulley there. I bought the pulleys. I had the cable. And then, I mean, everything else was just scraps and pieces. So 20 or 50 bucks for all of this, in my case. But I think that most people could probably do this for, if you had none of this, probably $200 at the most, including the garage door opener. You know, let's say you'd pay $75 for the garage door opener, get some angle iron, and it could be smaller than what I used for all of this. This is, again, just bed frame stuff I had on hand. I had these crappy plastic junction boxes. I knew I would never use them for another project. I had a ton of these blank face plates. I did buy the switches. I had the speaker wire. So my design was based largely around what I had on hand, but I think it ended up pretty close to what I would do if I was doing it. If I had to buy the materials at each point, I don't think I would do much differently in the fundamentals of this. The pulley placement's a little weird for the counterweight. I don't have a better idea of that. But there's probably something that could be done better there. These pulleys are really cheap. I had to oil them to get them to run well. They were binding originally, and the cable was slipping on the pulley instead of the pulley turning. But that was just the cheap pulleys available at Home Depot. The biggest thing I would do differently, and it's still pretty small, I probably would have welded this track. If I had thought about it, I would have welded the track while it was all, before putting the garage door opener up in the air. Mostly because it was just awkward for me to weld these in position, or in place out of position. If you don't have a welder, you could do this all with nuts and bolts. To fill in the gaps in the track, you could probably clean all the grease off and use some JB Weld to fill it in, and then that way the carriage won't bind. Because again, the carriage is not meant to run vertically on the track, and it's trying to hunt and you know, under load, it's trying to do this all the time, you know, coming out from the wall like that. So it's going to want to bind on any of these things, versus if it's running flat, it will travel across the bumps on, you know, when it's running parallel to the ceiling much more easily. That's probably the main thing I would have done differently. Again, what I did was largely motivated by what materials I had on hand. I probably would have made that bracket at the top a lot lighter. That piece of angle iron probably weighs as much as the garage door opener mechanism end. So this would have been a lot easier to lift into place without a come along had I not used that angle iron, but it was a design convenience because I had the material at hand. I think that's about it. I will add anything else I think of in the comments. But I hope this helps anybody who's thinking about doing elevated storage, thinking about how you can get things up and down safely, and what you might consider when planning a lift or some other solution like this. Thanks for watching.